This bath here is for the heating element. I'm filling it mostly with distilled water. There's a line here, that's the minimum. There's a line here, that's the maximum. I'm now adding some tap water. So it's mostly distilled, but a little bit of tap in there. We have a pump that's an aspirator type pump. It will pump water through these jets, creating a zone of low pressure using Bernoulli's principle. The aspirator pump sits on top of a tank of water as shown here. The switch to turn on the pump is in the back. You can see the water is being pumped here at a rapid velocity. Normally we cover this area so that no water splashes out. The vacuum itself is carried through these tubes over to the actual Rotovap device here. The vacuum first pulls air out of this chamber up here. The vacuum is transmitted to this bottom chamber here, and it's also connected to the side port right here. And this is where you put a flask. I will demonstrate evaporating some ethanol using the Rotovap. The first thing I will do is to turn on the heating bath. To turn on the bath, there's a master switch here. When I flip that, the light goes on here. This is the temperature dial. I want this to be about 35 degrees Celsius, which is warm. I press the on button, and I've set the dial to about 35. The position of the bath is adjustable, so depending on the size of your flask, you can move this bath appropriately. I will now fill the trap with a coolant. There are two types of coolants we use in ACR. For higher boiling solvents, I will use wet ice, normal ice, water ice, plus distilled water in my trap. If I'm evaporating dichloromethane, I need to put isopropyl alcohol, and dry ice in the trap here. I'm pouring in distilled water. That's enough. And I'll put in, looks like 4 cubes of ice from the freezer. Gentle here. If you break this trap, it's probably $700 to replace it. So, gentle. Our bath does not have a temperature gauge, so we have this thermometer handy. So it's about where I want it to be. It's at 32 degrees Celsius. We have 2 sizes of standard flasks in ACR. This smaller one is a 25 milliliter. This is a 100 milliliter. Notice they have a pear shape. The flask is designed that if you had to scrape out a solid, you'd be able to reach every surface with your spatula. These cork rings are specifically designed to hold flasks of this nature. This will be my flask, my demonstration flask. I've put about maybe 10 milliliters of ethanol in here. We have this device which is called a bump trap, which should be first attached here. Now I can attach this flask at the end here. Before I do that, I'll put just a wee bit of vacuum grease onto the ground glass joint here. Just a wee bit. This will prevent the joints from sticking together. Now I use a keck clamp to secure the flask to the bump trap. A keck clamp has a bigger ring and a smaller ring. The bigger ring should go to the bottom, the smaller ring goes to the top. My system is now ready to do the actual evaporation. The first step I will do is to start the flask rotating. It's a rotary evaporator. So I'm turning this dial here that says RPM. Between 100 and 150 is a good rotation speed. Now I will pull a vacuum. I will switch on the pump. I then need to turn this valve, and as I turn it 180 degrees, this gauge will start measuring the vacuum. This is now measuring the vacuum. You can see the vacuum is being pulled here. It should get to about 740. The maximum vacuum you can pull with an aspirator is down to about 20 torr, 20 millimeters of mercury. On this side, I'm feeling the temperature of the flask. Evaporation is endothermic, so if the ethanol starts evaporating, the flask should get cool. You can see now there's fog on the outside of the glass. It's getting cold. I will lower the flask into the bath, push down, and gently, slowly, gradually lower the flask into the bath. You can imagine if you did this poorly, you shear off the glass. So you're very gentle as you lower it into the heating bath. On this side, the level of the ethanol in the flask is below the level of the heating water. That's just as it should be. Here we can see droplets of ethanol condensing on my cold trap. So this is the ice water trap. The gaseous ethanol is pulled by the vacuum to this chamber, but here it gets chilled. And as it gets chilled, it condenses back to liquid, which drops off the end of the cold trap and collects down here. Now I'm watching the solvent here left in the flask. I'm evaporating the dryness, so I just wait until it's all gone. The total time it should take is about 5 minutes or less. If your time is taking longer than that, it is recommended you turn up the temperature of the bath to increase the rate of evaporation. I'm keeping an eye on my trap. It looks like I should add a little bit more ice. Keep it cold. Looks to me like this is pretty well done. I can raise the flask to get a better view. Here I've stopped the rotation. I can wipe the outside of the flask to get a good view. I don't see any liquid remaining, so that means I'm done here. To shut down, first I must release the vacuum. So I'll turn this knob and I'll hear a whoosh of air. Now I can turn off the pump. Don't turn off the pump until the vacuum is released. Now I can go over and remove my flask. Careful, don't snap off the glass bump trap. And there's my dry flask. Before I leave, I'll turn off the bath. The solvent that collected here can be put in the organic waste. I turn this knob so that I can release the clamp. And then I can very carefully transport this and pour it into organic waste.